Hello everyone, welcome to this video. In this video, we'll be solving question 15 from miscellaneous exercises of chapter 9. The question here says if the pth, qth and rth term of an AP A, B and C respectively, then we need to show this thing. Now at one point of time, I also saw that whether this is a repeating question or not. Actually it is not. We have already solved a question on pth, qth and rth term, but this is a different one. So let's solve this one. So here they are telling you that for a given AP, the nth term an is given by a plus n minus 1 times of d, right? If we take capital A as the first term and capital D as the common difference, so this becomes our nth term. So here for this particular term, what would be a pth term? It is given to be equal to AP. Right, it is given to be equal to a, and here if you substitute in place of n the value of p, so it would be AP is equals to a plus p minus 1 times of d, and this is what I have written over here, which is our equation 1. Similarly, the qth term would be a plus q minus 1 d, and it is given to be equal to b. Right, this is our equation 2, and similarly AR is a plus r minus 1 times of d, which is given to be equal to c in the question. So let's mark this as equations 3. Now we have to simplify these expressions. Now in order to simplify this expression, we would require quantities like this: q minus r, r minus p and p minus q. So can you see a way by which we could obtain these quantities q minus r, r minus p or p minus q? Right, so let's have a look. Q minus r could be obtained when you subtract them together, right? Similarly, r minus p would be obtained when you subtract this and this, and p minus q would be obtained when you subtract these two together, right? So let's do that and see where we reach. We first of all wanted the term q minus r, so we are subtracting them both. So what we are doing, we are subtracting equation 3 from 2. So let's write the left hand side first of both with the negative sign in between, and then we have b minus c, correct? Now you can simplify the terms. This is plus a, this is minus a, they get cancelled. You have d common, so you can write d common, so you have q minus 1, and here because you have one minus sign outside, so it is minus r and it is plus 1, right? This is equals to b minus c. So you see this plus 1 and minus 1 gets cancelled, so you have q minus r into d is equals to b minus c. Or what is the value of q minus r from here? It is b minus c upon d. And actually when we wanted to prove this, we want a with this term, so let's take that also. We can multiply both sides with small a to get this. So once you have this, you can mark this as equation number 4, right? Similarly, we can subtract equation 1 from 3, so that we have the left hand side subtracted and the right hand side separated separately, right? Again, this a and a gets cancelled. You can combine the d term, so r minus 1 minus p plus 1, this 1 and 1 gets cancelled. You can shift this 2 to the right hand side, right? And we want, because b with this term, so you can multiply with b on both sides. That makes no issue, so let's mark this as equation number 5. Similarly, we can subtract 2 from 1, so the left hand sides gets cancelled, a terms gets cancelled, d could be taken common, then plus 1 minus 1 gets cancelled, so you have q minus p into d is equals to b minus a. So similarly, because we wanted c here, so we can multiply c on both sides to obtain equation 6. Now for the proof, because we wanted to add all these terms, so what we will do, we will add our equation 4, our equation 5 and our equation 6, right? Equation 6 is what? It is this one. So that our left hand side would be exactly equal to what we wanted to prove, and we can see what our right hand side become after adding. So once you add, you have this as the left hand side of what you wanted to prove, right? And here you have these terms. So what you can do, you can take 1 by d as common because it is appearing in each term, and you can multiply the terms in within the brackets, right? So that you would have ab minus ac, right? Then you have bc minus ba, then you have cb minus ca. Now you see ab is exactly equal to ba because multiplication is commutative. This is equal. So, and they have opposite sign, so they cancel each other. AC is equals to ca, right? They are the same. AC is equals to CA. So they also have opposite sign? No, they don't have opposite sign. We have to check this thing over here. Let's check it. Okay, so I found one mistake here. When we were subtracting 2 from 1, we should write here A minus B, because the quantities from first would be written first, right? It should be A minus B, right? So here is A minus B, so here also we are having A minus B, so here also we are having CA, and here is CB, right? So that now this AC and CA, they gets cancelled, and this BC and CB gets cancelled. So you are left with 1 by D into 0, which is equals to 0. And this is what we wanted to prove here for this particular question. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.